Okay, everybody, nice to see you all here. Welcome to the 13th in our series of CAQDAS webinars. I'm Christina Silva, and I'm joined here today by my colleague Sarah Bullock in chairing this session. These webinars are delivered by the CAQDAS Networking Project, which is based at the University of Surrey in the Department of Sociology. Before we get going with our webinar today, just to remind you that we've got several more webinars scheduled before the summer, so please do keep an eye on those and register and join us for them. Some really exciting topics coming up. All of our webinars are recorded and you'll get sent a link to the recording of this one along with our YouTube channel where you can access previous recordings as well. If you're interested in contributing to our webinar series, please do get in touch. We're always interested to hear from users and methodologists and teachers, as well as developers of CAQDAS packages. I'd also like to just draw your attention to the range of online training that we have coming up as well, all of which is currently still subject to some significant discounts that we're putting on to support the students and researchers whilst we continue working from home predominantly. Okay, so on to the main event today. As I said, this is our 13th CAQDAS webinar this academic year, and we're delighted to have Dr. Stephen Gourlay with us from Kingston Business School, who's going to introduce us to Descending Hierarchical Classification and its implication on computer-aided thematic analysis. Stephen is an associate professor at Kingston Business School, where he's recently finished a stint as the head of the Department of Management. He's undertaken a wide variety of research projects and has a substantive interest in health management, amongst other things. Stephen also teaches research methods to postgraduates, and he specialises in the analysis of text. And it's this experience that he's going to be sharing with us today. So we're really looking forward to hearing you speak, Stephen, especially your reflections on the role of software in analysis, and also to see you demonstrate an open source software that we're not very familiar with. So that's going to be really exciting for all of us, I'm sure. As a long-term user of CAQDAS packages and an early adopter of the program Qualrus, that was one of the first to provide analytic assistance, Stephen is really well placed to discuss this ever increasingly relevant topic of computer assistance for qualitative analysis. Whilst Stephen is speaking, please, all of you, feel free to post your questions or comments in the chat function of the Zoom meeting, and Sarah and I will collate them and then pose them to Stephen when he's finished his talk. So, Stephen, thanks very much for being here today. Over to you.
Thank you very much for the nice introduction, and thank you for the opportunity you've given me to talk about one of my favorite topics. Qualitative data analysis is a phrase I tend not to use. I tend to talk much more about text analysis, but more about that in a second. So hopefully you can see my slides. Right. Okay, I had a bit of difficulty about the title for this session, because does anybody still carry out their analysis? Probably not. Well, it's not so long ago I had a student who used rolls of wallpaper and post-it notes to manage her process, but since then I've never had any student do anything other than using computers. So, but it will do for today, because it's pointing us in the direction that we want to go, of really specific forms of computer-assisted assistance and facilitation of thematic analysis. Right, okay. So I thought I'd just start off with a context related to the area of qualitative data analysis, since that's the kind of forum that we're in. And on this slide, I've just listed a number of techniques. I'm sure you're all familiar with most of these, if not all of them. So at the top, we have from content analysis down to qualitative content analysis. We have techniques which are general. Rhetorical, narrative, and discourse analysis are perhaps useful to categorize as connecting strategies in the language of Maxwell and Miller, who distinguished the connecting strategies from the data reduction strategies. In conversation analysis, I can't make up my mind whether it fits into either of those, but it's sitting there at the moment. So when I started out teaching and using these techniques, I always thought of some of these, particularly content analysis, grounded theory, thematic analysis, as techniques for analyzing interview materials and so on. And then for reasons that I lost deep in the recesses of my mind somewhere, it occurred to me one day that what we're doing, we're analyzing text. And for most of us doing qualitative research, we are analyzing text. Yes, I know there are people who analyze still images and people who analyze video, but by and large, that's still a rather niche area. We're all analyzing text. So what about text analysis? We're not the only people who analyze text. And because my second home is Google, I started finding all sorts of interesting things that intrigued me. And I came up with an addition to the list of techniques that we can use. Now we can think about these as being divided into non-statistical techniques and statistical techniques. So there's just a short list there of some of the techniques for dealing with text which use statistical techniques in various ways, either to manage the output, as in classical content analysis, or sort of behind the scenes, which is what's more the nature of the technique that I'll be talking a bit more about later on. I'm not going to go through all those kind of things. It's just to illustrate that there are a lot of other techniques that we can use and apply to textual material that allows us to find potentially interesting patterns in the material. And that's, I think, fundamentally what we mean by analyzing data. We're trying to look for patterns in the data, patterns of the text that are interesting to us from the perspective of the research questions that we're trying to address. A slightly different perspective on the general field comes from a German researcher who, thankfully for me, is publishing stuff in English. And in this case, it's a review, a diagram from his review of software for analyzing text. It's helpful, I think, here because it includes the CAQDAS area or the CAQDAS kind of approaches in it. So he suggests there are two dimensions on which we can plot a typology of text analysis software, which I've annotated with the blue. Have many documents or a large corpus, many thousands of texts, and down to smaller numbers, or even one document perhaps. The horizontal dimension we have on one side, we have an interest or focus literally on words and perhaps even on parts of words. And at the other side, we have our interest and a focus on meaning. CCA is Wiedemann's abbreviation for content analysis. And in this case, he's particularly thinking about dictionary-based techniques, dictionary-based software, where you are literally interested in words and perhaps phrases. CQDA is his abbreviation for CAQDAS kind of programs. And lexicometrics is a generalized term very much associated with the French tradition of text analysis and of computer-based and computer-assisted text analysis, which is kind of where we're going to go today. What I'm moving on to now is I'm going to introduce you to the specific technique and to briefly outline the processing of text that is done in the technique with the algorithms, go through some slides illustrating some of the output, and then I'm going to switch to the software itself and do a quick run through on the software, which I always think is more interesting than listening to somebody just talk about the software. So the technique that I'm going to introduce has various names. I've decided to focus on a descriptive phrase which refers to the technique that is fundamental to it, is foundational to it. And that's the technique of descending hierarchical classification. The technique is also known as the Alceste technique, after one of the first programs in which the technique was implemented. Another program, which is the one I'm going to be demonstrating today, is called Iramutek. And within Iramutek, this is referred to as Reinhardt's method, since Reinhardt was the person who developed the theory, which was then later implemented as a computer algorithm. The Alceste acronym, even translated into English, gives us really quite a good quick summary as to what this approach is in the software. So it's through an analysis of co-occurring lexemes in a collection of segmentations of text that we create a descending hierarchical classification of the different classes or different categories of text segments. And hopefully those classes of text segments tell us something about the different kinds of things that are being written about or talked about in the text. So these techniques have arisen very much largely in France, and in that context, theory, particularly concerned with social represents quite a large literature. I've only personally just touched on the edges of it, so I wouldn't count myself as particularly knowledgeable. But the basic assumptions seem to me to be similar to many of the basic assumptions of anthropological research. And I think there's some analogy, at least, between social representations, as they talk about it in social representations theory literature, and themes, as certain anthropologists have defined them. The basic assumptions of social representations theory I've listed on there, which are that we communicate with each other, and particularly in communicating with each other in our societies, we have different ways of talking about whatever the things are that interest us. So in that way, we build representations of aspects of our social reality. And those representations are structured in these cognitive, social, and semiotic ways, embedded in, or embodied in, if you like, but certainly embedded in communicative practices, and therefore embedded in language and structured by linguistic practices. And therefore, by analyzing communicative texts, we can start to identify what those structures are, which will then give us an insight into various facets of the society that we're looking at. Another way of looking at this is to think in terms, as Reinhardt put it, of lexical worlds, that we all inhabit lexical worlds. And Reinhardt proposed this method as a technique for systematically identifying lexical worlds based on the characteristic vocabulary of each world by using statistical techniques to find characteristic vocabulary patterns in the text, and therefore to permit further inferences about what's going on amongst the speakers or the writers. Some linguistic assumptions also underpin this approach, and those are some of them quite long-standing. So a quote there from 1957, a linguist who has this quite famous phrase that you shall know a word by the company it keeps. And that idea seems to be a very common one in certain aspects of computer-assisted text analysis. And is a slightly different approach from that associated with, for example, topic modeling, where in topic modeling, you tend to disregard the word order and therefore the company that a word keeps. And in this approach and a number of other computer-based approaches, we explicitly retain the linguistic structures, and we use the linguistic structures and the relationships between words as they are set out in the actual inferences about what people's basic themes were that they were talking about, or their basic social representations. In computing science, there's something called the word space model, which is the computer algorithmic representation of this kind of patterns. I'm not going to say any more about that at the moment. So what has descending hierarchical classification been used for? This is just a short list of some of the categories of research that I found in management and business studies, there's quite a lot of specific studies. There's been research on stress at work, organizational culture, analysis of consumption. It's also started being used for conducting systematic literature reviews. And the example I'll show you in a little bit, a little later, is where I've taken the abstracts of articles from the bibliographic database, and then applied the technique to try to help me identify what kind of theme, relatively large set of article abstracts had, what had they actually been writing about, to help me understand what sort of topics were covered in literature, other than the main one that I was interested in. The technique has also been used for the analysis of open-ended survey question responses, whether they were written responses in the typical phrase response to a question, well, please tell me a bit more about your thoughts. And other kinds of survey responses, open-ended survey responses, where people could choose from a selection of words to characterize their description of whatever it is they were being surveyed about. So in other words, it can be small sentences, or it can be just a set of words which come from a database, come from a set offered to people to respond with. Most of the publications, or a large number of the publications, are in French. There's a small amount of literature in English. I'm talking about the research output now, and also quite a large output in Portuguese, and was having a discussion before the seminar started, discussing different uses of Portuguese in different parts of the world. But this seems to be a community of researchers in Brazil, in particular, using the program I'm going to demonstrate to you. I'm going to move on now to just illustrate in the slides how the program works. So we have to assume for the moment that we've already created our data input files, and in this case, it doesn't matter what the text says, but in this case, this slide is illustrating what a section of the data input file. So we have the first line, we've got two records here, which are called initial units or source text. We have a line of instructions for the computer, starting with 4 asterisks, and then the text others. It has some other underscores joining things together by software to be loaded into the Lemmatization program or the Alcest program. It's basically the same process. But what the program does, first of all, is that it identifies what are called in Lemmatization elementary context units or text segments. So what it does this by taking note of punctuation and taking a unit which to define how many characters are going to be included up to the punctuation. So in this particular case, is the illustration of that. So there's 4 text segments. And the way the processing works then is that the text segments are analyzed and compared to each other, and finally created classes of text segments are created in this way. There's some other pre-processing steps. One of the most laborious parts of working in this way is the data cleaning process. So you take the texts, in this case, I regret in retrospect having started out on this with bibliographic records, because you have to confront all sorts of problems that you wouldn't have to confront if you were doing some interviews, for example. So standard data cleaning means you decide what to do about certain punctuations. You can't use apostrophe, so you have to decide how you're going to represent or retain the apostrophe words in the analysis process. In the case of bibliographic records, you have additional problems of people using acronyms. So you have to decide, are you going to expand the acronyms, or are you going to collapse the phrases into acronyms? Because you're not interested in whether or not somebody uses an acronym or a phrase. you're interested in the sense of that phrase and where it occurs. You've also got different spelling conventions turning up in bibliographic records. So you've got to standardize on Z spellings of English words or S spellings of English words, because otherwise computers can't tell the difference and it will treat them as different things. You can choose whether to lemmatize or not. Now, lemmatization is another process used in a lot of computer-based software processing of text in order to simplify the number of forms of words and to try to identify forms of words that have similar meaning and bring them together. And generally speaking, it seems to work. Occasionally it doesn't. And I've given you some examples on there of if we've got those words affect, affects, affecting, and affected, they will all be treated as the word affect. And of course, the different forms of the verb to be will be changed. One of the next things is the grammatical filtering process into two groups, one which is called active words, one called supplementary words. So the active words are chosen because they are typically the most informative words, and the supplementary words are words that exist in the language but support and complement the meaning. And finally, the statistical filtering process. We don't bother to look at numbers of words that only occur very infrequently. Excuse me. So this is just a diagram illustrating the process. The diagram itself is mostly in French, but it's not difficult to understand what it's saying, and I've given an English supplement at the bottom. So this is basically how the program, the algorithm processes things. And once you've got the active forms and the supplementary forms identified in the different text segments, the algorithm then creates clusters or classes of the words according to a classification. This slide's just illustrating what it does. Fundamentally, what the algorithm does is it divides the whole set into two, maximizing the difference between the two, and then it takes each of the classes and subdivides them again to two, and goes on until it can't create differences between the two, and in this way produces this hierarchical top-down classification system. Here's an example of some output, what it produces. So you can then get the Mutec program to create this diagram showing you, in this case, we have 5 classes, and you can see they were split into 2 classes. One of the classes was split into 2, and then the other class was split into 3. And we get lists of the characteristic words associated with each of the classes. The final step is where you then start working on that material. You need to look at those materials, look at the word lists, look at the phrases and so on that are associated with the categories, and decide whether it's meaningful in the sense of being semantically consistent and giving you an insight into a particular idea, something that makes sense to you. I think it's very important to understand this because, well, as with in the past with CAQDAS, there was the misunderstanding that the software would analyze the data for you. We have exactly the same situation here. The software does not analyze the data for you, although it does, in a sense, it depends what you mean by analyze, but you still have to work hard on the output in order to interpret the output. Well, first of all, to decide whether or not the output is meaningful, and if not, rerun the analysis and tweak the inputs, which you can only do with an awareness of what is in the documents. You can then start to move forward and start to use that to write up your analysis. As Chartier and Vernier say, this is an iterative abductive inference process, going through these 3 general kind of steps. So that's the slides. You can see I've given some references there for you to have a look at. And now hopefully I'm going to be able to show you the software I know how long the slides have been on, but I don't know how long. What's my timing? Sarah,
So
Christina, how am I doing?
You're doing great, Stephen, timing-wise. You've got maybe 20 minutes or so. Before you get going, Stephen,
yes?
Can you hear me?
Yes, I can.
Sometimes your voice is flickering in and out a little bit. I wonder if you want to just turn off your video for this bit, and that might increase the bandwidth a little bit.
Okay, I'm happy to do that. Yes, I kept getting an odd message saying that I've got poor connections or something.
Yeah, we can hear you most of the time, but there are a couple of occasions.
I
can do it for you, probably.
That's all right. I think I've done it.
Okay, fabulous. Yep. Thank you.
Okay. So, okay, you can all see the front screen of the program.
Yes, thank you.
Thank you very much. Right, okay. So this is a program which is a piece of open source software. It's been developed by people working in these research labs in France, and is put out there like all free software for you to use as it is. As we go through, you'll doubtless spot quite a few bits of French popping up. A lot of the menus and instructions have been translated into English. When you install it, everything's in French, but you can change the language to English. But even so, it's still a piece of software that you'd expect from commercial software, but it does the job for which it's designed to do. And the developers keep tweaking it and updating it. I don't know how far they intend to go. Okay, so how are we going to work it? Straightforward, you go and open a text corpus. That's your text file. This is one of my extracts of some bibliographic records. Just open it, and you have to set it up you have to tell what the character set is in. I tend to use something called UTF-8 because that suits other programs. I suspect you could use an ordinary output from a plain text editor. You need to change the language, in this case obviously to English, and you can see that there's a number of other languages supported, although a lot of them are still experimental. Select the dictionary, so I'm selecting the default English dictionary. I'm not going to alter any of the other parameters at the moment, but you can alter all of these things. Click on OK. Wait for it to process. It sings you a little song, which for some reason you don't seem to be able to hear at the moment. And this is the first output screen. Unfortunately, when you're doing stuff live like this, it's not possible to enlarge the screen. So I'm sorry about that. You'll have to bear with me on that. So we have a basic description of what's in here and what the software has done for us. So we have the file name in English, the character set, where it is, etc., the date, how long the processing has taken, and so on and so forth, and we don't need to bother too much. More informative for us is that we've got 142 records in here, which I know that's correct. It has been divided into 731 text segments. It has 26,000 odd words, 3,790 odd different words, and 1,738 words that only occur once. So it gives you some basic statistical information about the characteristics of the text. There's lots of options we can go through. You can either use the icons or you can click on text analysis. I'm not going to go through any of these. If we have time and somebody's interested, we can perhaps look at them. I'm going to show you the Descending Hierarchical Classification method, which in here is called Reinhardt's method. So we just click on that, and we have some more settings. These are the default settings. I'm not going to change them for this demonstration, but lemmatization is on. It's using the index, and just click on OK. We have another option, setting options here. We have three different ways of processing the texts. Generally speaking, the one that's in the middle here that I've chosen on a previous occasion, and it keeps that setting, that's going to be the one appropriate for these kind of texts. In that case, we don't need to alter anything down here at all. We just click on OK. And as it says in French, please wait. So this software uses the R computing environment behind the scenes. And what you see in the little black screen there is it's just showing you that R is doing things. You don't need to take any notice of that at all. I suspect in a more polished piece of software, you would not display that, but it does display that. This seems like a long time when we're sitting here watching the screen and waiting for something to happen. But from previous experience with this data set, it takes about a minute. Perhaps I should just say at this point, if you try running this on some text of your own and you're certain that you've formatted the document correctly, and you get error messages popping up, the developer is extremely responsive to people who have problems, and you can just post an email to the help site, and typically you'll get a response within 1 or 2 days, either from the developer or one of the other frequent users of the software. Okay, so it's told us there are 4 classes in here that we can see straight away down here. So we're looking at the listing again, 142 texts, that's good. Nothing changed there, so everything's still working all right. So this repeats some of the information we had before. We've got some additional information here, the number of lemmas, and the number of active forms, and the number of supplementary forms. Remember, active forms are adverbs, adjectives, nouns, and verbs. And supplementary forms are all the other types of grammatical types of word. So we've created 4 clusters and we've classified 93%. So that's nice. If we'd only done 60 or even 70%, we might have been tempted to go back and tweak the parameters to see if we can get a better use of the materials. So here we are as our first display. We have the 4 classes, and as you can see here, we've got divided into 2, and each of them is divided into 2. And the little diagram down the bottom just gives you a little bit more detail of how the program operated, showing you that it tried further possibilities and rejected them all, and leaving us with the 4 classes that we've got here. Up here you can see we've got 3 tabs, and we're in the first tab, which is labeled CAQDAS, which is the French abbreviation for Hierarchical Descending Classification. We have another one called Profiles and another one called CA, which we will have a look at those 2 shortly. And we have these 2 other icons here, both of which do pretty much the same kind of thing. So I'll show you the first one for the moment. So what this is going to do is to create the list of words under each class, like you saw on the slide. I'm going to leave the default settings and just click on OK. A bit more processing taking place, and here we are. We've got our 4 classes with the characteristic words underneath each of them. So this gives you a first quick insight into the characteristics of these 4 classes, and assuming that that's what we accept as sensible and useful, of course that will be what we use for our analysis. Just a quick look at these tells me, you can see here it says interview, qualitative, participant, incident, week, datum, mind, method, site. So apart from mind, which is a bit puzzling there, these all look like methodological words. And if you cast your remember we're looking at abstracts of articles, and typically abstracts of articles will start off by telling you about this is what we did in terms of what were the topics, or what was the research site. Then there'll be a couple of sentences about the methods, and there'll be some sentences about the results. So this looks like the kind of sentences you would see, the content of sentences to do with the research methods. Care, patient stress, staff, resource, support, code, nurse. Well, this seems to be all to do with medical environments or healthcare environments. The bibliographic records in this set are from a search on the topic of workplace spirituality. And a lot of research in workplace spirituality has looked at healthcare environments. So that doesn't surprise me at all, that we've got a cluster or a class which is focusing on healthcare. These other two, at the moment, seem to be more difficult for me to say what's the difference between them. The software, the statistical algorithm is saying they are different from each other. There is a different distribution, but whether that distribution difference is meaningful to me or not, I'm not sure yet. Because both of them are to do with features of organization or running organizations and managing organizations. This one seems to be a bit more about managing jobs and managing employees. OCB is an acronym for Organizational Citizenship Behavior. We've got satisfaction in there. But this is a bit mixed. We've got research literature, we've got article, we've got something which I don't know what on earth it means, and so on. And if you're wondering why we've got things that I don't know what they mean, it's because this run tells me, one of the things I learned from this run is that I need to go and review my data cleaning, because I still have some things in here that look like words like SQ that I need to understand what they mean. They're sitting in the abstract. And also I have spelling variations, as we'll see shortly. This other one down here produces little word clouds of these things. So that's nice and pretty for putting in a paper if it's suitable for you. I'm going to stick with the graphic displays for the moment. So I'm going to go to the CA tab. And CA is correspondence analysis. And correspondence analysis is an exploratory statistical technique for working with categorical data. In this case, the categorical data is in the form of text or words. And what this diagram shows us here is, first of all, we need to have a look at factors. So factor 1 is 41%, factor 2 is 32%, which gives us 70. Sorry, my internet connection was unstable. Internet connection was unstable there. 73% of the data has been accounted for in this diagram. So that's quite good. Sometimes you run the correspondence analysis and you get the totals coming to 20, 30, 40%, and so you know much of it's not been accounted for. Here we can see that most of it's been accounted for. Now, if there was no difference between the distributions of these words in the text, we'd find everything clustered around the center. What we in fact find is that our 4 classes are one in each different quadrant. With a lot more time spent on this, in principle, this is the principle of correspondence analysis, you would be able to identify some similarities between these two, which are different from these two, because these two are above and these two are below the line. Similarities between these two because they're on this side of the central line, and so on. But the basic thing it's telling us here is that there are 4 groups and they are quite separate from each other. There's very little overlap, a tiny bit of overlap there between the blue and the red. Go down the screen, it gives us I've forgotten what they call them in here. The supplementary words, that's right, which aren't really very helpful. And then what it gives us is the record numbers, which is nice and very helpful, because I can now say, well, if I go and look at these record numbers, I expect them to be about whatever the blue one is, and these ones are about the purple one. So that's very helpful to me. The CA tab itself has more information in here. So it's showing me here that we've got, as I said before, 73% of the data is accounted for by 2 factors, which leaves 26% accounted for by a 3rd factor. And we can rerun this to look at factors 1 and 3 and factors 2 and 3 to see what the patterns are and if they really make a difference to the overall picture. 3D graph is a more complex way of displaying all 3 factors, as they're called, on the same graph. I'm not going to go there. I'm going instead to look at the profiles. So here we have the detailed statistical and textual information about each of the classes. Here they're called clusters rather than classes, but the tendency is to try and use the word class to get away from the implications of cluster analysis. So each of these tabs contains information about the 4 clusters. It's got the list of characteristic words with the most defining words at the top of the list, and some other statistical information over here, which if we've got time and I've got a question, I can go into and explain that. From here, we can do other various things. So, for example, well, we can click on any one of these words, do a right click, and we can get other information out of this. Click on associated forms. That's not very helpful there. That's not very helpful there. Must be something somewhere. I just wanted to illustrate to you what happens. So here we are, yes. Just to illustrate what's happened with lemmatization is the words relationship and relationships have been treated as the same in the processing. So here we can see, you can see here these are the type of the word, grammatical type. And we can also look at things by, we can get some little information about how does this word occur across the different things. We can see the word commitment only occurs in class 4. It doesn't occur in the other classes at all. So we get an idea of how, where this word distribution is in relation to other things. There is a lot more that we can do, but I think probably I'll stop there to give time for people to say, will you show me something else, or to answer some questions. So back to you, Christina and Sarah.
Thank you so much, Stephen, for that overview. Really interesting, and there have been lots of questions coming through, so that's great. I'm going to turn to those pretty quickly now. So the first question is from Anne. Anne asks, if possible, can you give a small insight into how the cluster output helps you produce the analysis? So you've shown us the visualization of the cluster diagram, and then how that then translates to the list of the words. Yes. But if you were then doing a piece of work with this, Stephen, what would your sort of next steps be here?
Okay, well, the first steps are to have a look at these and start to just eyeball them and say, well, does this kind of make sense? And as I said, this collection looks like terms to do with research methods. That's what I should say. What our interest was in this was partly what our interest was in doing this was partly experimental, saying, oh well, let's try this piece of software out and see what it does for us. But partly thinking that, well, you know, I've downloaded 100 and odd, nearly 200 odd bibliographic records. How long is it going to take me to read all of those through and to start to get a sense for what kind of topics have people interested in workplace spirituality studied? What kind of environments have they done workplace spirituality studies in? And that was our intention. So in this case, for example, we weren't particularly interested in the methods terms. You might equally have an interest to say, well, what methods have people used to do empirical studies in the broad area of workplace spirituality? In which case you'd be particularly interested in looking at more detail at this cluster here, or this class.
Okay, that's helpful.
Then I would go to the profiles, and I would start to have a look in a bit more detail here. And you can see right over on this side, we've got p values, which are standard probability values. So all of these ones with tiny probabilities, these ones, I suspect all of these don't occur in any of the other clusters or classes at all. So I've just chosen the bottom one there. Now again, you see, so implication, whatever that means in this context, doesn't occur anywhere else. And as we go down the bottom of the list, we find words that if you do that little mini analysis, you'll see that some of the words also turn up in other classes. One of the nice things about this classification method is that it doesn't put a word in one class and that's it. It recognizes that the same word can have different, occur in different contexts and therefore have different meanings. Down the bottom of this display, you can see we get the supplementary words, but also then we get all the record numbers. So again, another practical use in this context would be to say, oh, those are the records where belonging to this cluster. Now let me look at the records. In terms of a more, if this had been a bunch of interviews, well, then I'd be saying, well, okay, there appear to be 4 different types of things. Are these 4 themes? Let me go and explore these. Again, let me identify the records or the passages that have these kind of words in them. Okay?
That's
help?
really helpful. No, it does. It does.
Okay,
Thank you very much. And do chip in if you wanted any additional explanations. I'm going to move on to a question. Well, there's 2 questions around language. So does the software work to analyze text in other languages? So apart from English and French, there's specific interests in Spanish and Chinese. Do you have any insight on those, Stephen?
I don't think it works on Chinese.
Okay.
I'm fairly certain about that. Let's just get up the list of dictionaries. But funny thing is, I saw there was some correspondence the other day, somebody working in Basque, asking him, does it work with Basque? And the answer was obviously no. Oh, sorry, I've done the wrong thing there. No, it doesn't, but you can create your own dictionaries. So, which isn't a trivia that are there, and it's possible to create your own dictionaries. So what languages? So we've got French, English, Italian, Portuguese, Spanish, and the others it says experimental. Now I looked at the French dictionary, and the detail in terms of grammatical categories is much finer than the English dictionary, which suggests that the English dictionary could probably do with a bit of tweaking. It's not perfect, but I haven't come across any serious issues with it.
Okay, great, thank you for that. There's a question from Norman around the algorithm that's being used here for clustering, whether it's a hierarchical k-means, and then whether there's any advantage of descending versus ascending hierarchical clustering in your view.
Okay, you're pushing me out of my comfort zone now, but I can try and give some received wisdom on those 2 questions. So my understanding is that the typical clustering methods are mostly bottom-up methods, and then there are a variety of those. The k-means is one of them. I can't recall any of the other names at the moment because I'm not familiar with those. But what I understand is that one of the issues is that there are a variety of those methods. And that's not to say that they should therefore be abandoned, but that they're not. You've got a number of different ones, so therefore you're then faced with the question, well, how do I choose between which one? And certainly custom practice leads you to prefer one over the other. Whereas the descending one, given the parameters that you start out with, for example, segment size and things like that, which you can adjust in this program, given those starting parameters, it's going to give you more or less, it's going to give you the same number of clusters or classes, so I understand. I think some of the ascending techniques also tend to say once you put a word in one category or one cluster, you can't put that word in another cluster. And from a point of view of language use, that doesn't necessarily make sense. And so that's why the descending approach is preferable to the ascending approach. So far as the algorithm itself is concerned, the best thing I can do is point you to the references at the end and look at Reinhardt's articles. They're freely available online where he's presented the algorithm. It's not within my competence to take you through those or talk about them, I'm afraid.
I think that's a really helpful pointer to those resources there. And Norman says, "Oh, sorry, Stephen, for putting you on the spot there." So
no worries. No worries.
Thank you. There's an interesting question here around combining the DHC method with other methodologies. So would it be possible, for example, or have you kind of come across people who would use DHC as a tool to perform some sort of exploratory data analysis to firstly discover and extract the sort of more meaningful themes and words, and then follow up with working on the interpretation of the given text passages by reading them in detail and applying a different kind of methodology?
Yes, the short answer is yes. And something I find interesting is that kind of approach is one that seems to be being talked about by some of the people writing from the computing and text perspectives. They're beginning to say that, look, this is just a tool to show you some patterns. If they're meaningful, well, that's great, and work with them. But you should also, other tools will give you other patterns, and you should actually use more than one pattern to give you different insights into the material that you've got.
Yeah.
I'm trying to think off the top of my head. I can't think. I'm very happy to look through my database of articles using the technique if anybody wants to contact me. But the one I can remember is actually looking at this technique and comparing it. I think it was comparing it with topic modeling, which is another algorithmic computer-based approach to analyzing text, taking a very different perspective from the Iramutek one or from the Descending Hierarchical Classification one.
I think that
so people are starting to combine the two sorts of things.
Okay.
Yeah,
thank you. Yeah, there was actually some interest in the chat about whether you had any articles that you could share where studies have made meaningful uses of these analyses, as it might help to kind of look at the value and affordances of running these analyses for making meaningful inferences. So as examples of them having been put into practice. So if at any point, Christina and I will be in touch with you after the seminar, but if you do have any particular studies that you know have used the tool, I think it seems like the group would be really excited to have a look at some of those.
Okay.
Thank you.
Can you'll send me an email, will you, and clarify what it is?
Absolutely.
Whether if it's just some general papers in certainly in English, I've collected quite a few.
Perfect.
I've got some in French as well, but they're much easier to find anyway.
Fantastic.
And if it's specifically just papers using two methods or two or three methods and comparing them, that will give me some focus for doing my search.
Great, and we'll circulate them to everyone present here. Another question that we have here is to do with data formatting and sort of what kind of formats the software can manage. So the question is the raw transcript generated from an interview that is pushed into the platform? So do you put the raw transcript in, or do the researchers have to work on their transcripts to clarify themes within them before using the software? And also what document format is acceptable to the software? So I think where you were going on your screen there was to the second question, which is what document formats can it eat, and do we need to do any work to it before we can put it in?
Okay. It needs to be in plain text, so not Word, not docx format or any of those other kinds of formats that belong with particular word processing programs, but plain text. And it actually, when the default seems to be one of the, so there are many ways in which text which characters are implemented in computers, and it comes up with one of them. And if you remember, I changed it to another one called UTF-8 because that's one I've got used to working in. But you don't really need to worry too much about those. So it's got to be plain text. It's got to be set out in a particular format. I don't know if I try, I'll take too long to get back to my slides. But so each record has got to be prefaced with 4 asterisks, or in fact 4 numbers, followed by a space, followed by an asterisk, followed by a set of variables. It's got to have at least one variable. So you can just have record number if you haven't got any, if variables aren't meaningful to you. And then set out in a particular way. Now, that was one of my stumbling blocks initially, and then I stumbled across a way of managing this without getting into programming. And I've actually drawn up a guide in English, which you can find on the Iremotec website. Basically, it means using a spreadsheet and creating comma-separated values, which are plain text files from that, and using some other, a tiny weeny little bit of computer-based processing of text to produce the program for you, sorry, to produce the file for you. Now, the example on the slides was simply that each record was treated as a single unit. Iremotec allows you to subdivide each record into what it calls themes. You don't have to do this, but you can do this. So, for example, if you've got a, let's say, for sake of simplicity, you've got a structured interview, and questions 1 to 5 are all background, and questions 4 to 6 are about how people used a new piece of software. You can put a theme indicator at the top of the background questions and a new theme indicator at the top of the software use questions and so on. You don't have to do that, but that gives you a bit more precise control over how the document will run it. I haven't done that myself, but on the Iremotec website, there's some researchers have translated a Portuguese version of examples, show the division of the corpus into these subcategories, which are called themes in Iremotec.
Great, that's really helpful. Thank you, Stephen. A quick question from Christina and myself here is to do with the amount of data that is needed to make this approach relevant. So in other words, is there a sort of threshold in your view of the number of words or records below which it wouldn't make much sense to use the approach?
Yes. I have seen some discussion about this for the Alceste program, and since it's the same algorithm, I assume it will apply to Iremotec. I haven't explicitly seen this discussed on the Iremotec website, but typically they talk about a minimum of 10,000 words. That doesn't mean to say you can't use it with fewer words, but you have to be more kind of skeptical about what it's doing. And like you should be anyway, you should be saying, well, does this make sense? Is it helping me? And if it's not, then you don't bother. But like a lot of this kind of software with text analysis, they are arguably more useful the larger your text, your corpus is in terms of the number of words in it. The number of documents doesn't seem to matter. I'm saying seem because I don't think it does. Because what is a document? It's up to you to define a document. You could create a document which has, well, you wouldn't have one word, but you could have each sentence and turn it into a document. And the analysis will still proceed, and it would be affected by the number of words as a whole.
Yeah.
So yes, we are looking at a larger corpus rather than a smaller corpus, and that's going to perhaps limit its use for small size interviews. Having said that, some of the examples I've seen where they were using it for looking at open-ended responses on survey questions, it didn't seem, intuitively, it didn't seem there were all that many words in total. So I suspect it's just a matter of experimenting at the moment.
Absolutely. Stephen, thank you so much. We've reached 5 o'clock. We have had absolutely no trouble filling this hour, and I think we could continue on for quite a lot longer. But I'm going to need to stop us here. And on behalf of Christine and myself, thank you so much for agreeing to do the webinar for us. And on behalf of everybody who's here, it's been such a pleasure to have you, and thank you for answering what were a lot of questions. So thanks everybody for joining us. Thanks, Stephen. Do keep an eye out for the recording. Christina will circulate that shortly, and we will also be sending you some of those resources we discussed with Stephen earlier on in the questions. And it would be great to see you join us if you can for one of our future webinars. We've got them scheduled till July. So everybody keep safe, keep well, and thanks for coming today. And thanks again, Stephen.
Thank you very much both for hosting it and managing the process.
You're so welcome. Thank you.
Thank
Bye-bye
you.
now.
Bye-bye, everybody.
Bye.
Bye, everyone.